You're listening to Behind the Wheels with Doug Mason, Dave Walters, and Mike Yeagley. This is a show where we talk about heavy truck and medium-duty axolans. Doug, Dave, and Mike bring close to 100 years of experience and expertise in the transportation business. Join us once a month to learn new things about axolans. Sponsored by Alcoa Wheels, the global leader in aluminum wheel innovation.
Welcome to another episode of Behind the Wheels. I'm Mike Yeagley.
I'm Doug Mason.
And I'm Dave Walters.
One of the questions we get over and over again from our customers has to do with loading and how loading works, what's going on, how you load a wheel, what kind of restraints, what kind of limits we have. So we're going to dedicate this whole episode to loading, to a discussion on loadings and some of the critical things that we find over and over again that hopefully it'll be really informative to all of you, our listeners. Let's just start off with some just general comments about loading. When a customer is going out and trying to understand loading of their vehicle, Dave, what should they be looking for? Where do they start?
Well, the first thing I tell a customer when he is, and again, some of them are after the fact and some are before the fact. So if it's after the fact, the guy bought a truck, you'd say, go open your front door and look, there's a little tag on your door and it will tell you the limits on your axles, your steer axle, your tandems, and it will tell you all that. When the OEM built that truck, they put the limits on the door. And what most of the people don't understand is the lowest limit, like say on an axle, it could be the lowest limit of the hub, it could be the wheel, it could be the tire, or it could be the axle. So people will say, well, I got an 18,000 pound axle. Yeah, but you've got technically you've got the wrong load rated wheel on there at 7,400 and the tire. So that's why your door says 14.8 or, whatever. So, going to the door is important. Now, if they call you before the fact and say, well, I'm speccing this truck out and here's what I'm going to run, it's easier to say, look, if you're going to put an 18,000 pound axle, years ago, Alcoa sent out a bulletin to these truck manufacturers saying, if you're putting an 18,000 pound axle truck manufacturer, you're going to put at least a 9,000 pound load rated wheel to match that axle, because we're getting a ton of warranty back from guys from these running the 22 5s, 8 quarters instead of a 9-inch or a wide base. So there's a lot of things that happens when it comes to loading.
It's funny because when it comes to speccing out the axle limits, and that's one of the things I go to when I talk to customers, one of the first questions I have is, well, what's your axle rated to? You can swap out the wheels, you can swap out the hubs pretty easily, relatively easily, but swapping out the axle, that ain't going to happen. So once that customer knows that axle limit, that is written in stone. They can start working around that. But like you said, they need to be careful about the wheels they spec out on top of that. Anything else, any place else they should be looking to start off when they're thinking about purchasing a vehicle, when they're thinking about what they're going to be doing, Dave?
What I always tell somebody, it used to be gross vehicle weight. Now, most of the CVSA inspections are per axle. So you kind of got to understand that I have an 18,000 pound front axle and 34,000 pound rears, and then my trailer's this. So now you got to realize whatever load I'm carrying, I got to make sure that none of these axles are going to be overloaded. So there's more thoughts into, and especially when you get into flatbed applications where they're hauling different loads with the same trailer. And, on a lot of flatbeds, that's when you get into the spread axle trailers, and they have to know where to put that load to center that load out and make sure that they can carry that legally.
Doug, one of the things I've seen over and over again, we'll get back to that spread axle because there's a lot there, I think. But I wanted to, first of all, talk a little bit about the difference between static loading and dynamic loading. And Doug, maybe you can take that one. What is the difference with static loading and dynamic loading? And specifically, how does that affect the wheel?
When you think about it, you get into a situation where you have just a point load. You're talking about a static load, or when we're talking about the dynamic loading, we're really talking about fatigue that's occurring as the vehicle is going down the road. And Dave has some good stories he was just sharing with us before we started the podcast about different customers that say, "Hey, I'm lifting this load and I'm placing it on here. And should I be concerned about that?" And we're like, "No, that's a static load. You basically have to get to the yield point of the material, which is significantly high relative to all of the stuff that's going on, before you're going to have any issue. You've got to create a yielding point out of that static to have a failure, and that would be just a collapse on the spot. But when you're talking about dynamic loading, you've got this cyclic load that's occurring, and there's a specific fatigue limit, they would call it, a certain stress level, load level that we're talking about, that if you exceed that for a certain number of cycles, you're going to start creating a crack in the wheel. And so many times we'll see where vehicles are overloaded, perhaps on different axles, and we'll talk about other situations where you can maybe not overload the axle, but you can overload the wheel itself by what you're doing, and we'll talk about that. Is now you've increased that load, that stress level to a point that in a finite number of cycles, you begin creating a crack in the wheel. So I don't know if that's kind of what you're looking for, but that's how I would maybe describe it, that difference between static and dynamic, and really creating a fatigue situation, which is what our guys on the road are going to ultimately see.
One of the things when I'm talking to customers and they're asking me, "Hey, can I?" Occasionally we'll give a customer an okay, an approval to overload our wheels to some specific weight rating, and they'll be looking for it, and they'll say, "Hey, can I overload the wheels by 100 pounds?" To throw a number out there. And the thing is, what they don't understand is, and we have to spend a little bit of time explaining to them exactly what you just said. If you're just talking about having 100 pounds but the wheel is not moving, it's just sitting there. You're just going to put 100 extra pounds onto the wheel. That wheel is not going to crack. What causes the wheel to crack is load plus distance traveled. When you have like and tires, the tire guys are completely different. They're worried about inflation pressure and they'll be looking at that. We're looking at the distance traveled at that load. And that's really getting into what you were talking about. How many times that wheel is going to spin around? How many cycles is it going to go through? Is it going to roll 1,000,000 times? Is it going to roll 500,000 times? Is it going to roll? Basically, if you think of a wheel crack happens, if you take a stick or something and you bend it back and forth and back and forth and back and forth, and it eventually will start to break. That's what happens with a wheel crack. It's not the load itself that does it. It's the load plus how many times it goes through that cycling. You can put a lot of weight. Our wheels can take a lot of weight if they're not moving, if they're just sitting there. Once you start moving, then it's how many times is it going to cycle? How many rotations is that wheel going to go through with that extra load? That's the difference between static and dynamic loading. The static is where it's just sitting there and just being loaded. And then the dynamic is where it's rotating at that extra load. And that's what kills a wheel, is when you have extra load and driving down the road for 100,000 miles. Well, that's going to cause a problem. So
That's like one cycle versus millions and millions of cycles, if you want to think of it that way. One cycle,
right,
huge load, many, many million cycles cannot.
right. And like going back to bending, if you have a piece of metal and you're trying to bend that piece of metal, if you bend it once, well, it's gonna, even with a lot of bend, it's gonna stay as one piece. It's gonna be okay. But when you start bending it back and forth and back and forth and back and forth, it'll eventually give. And that's what the cycles do, is they just bend it a little bit until it finally gives. The amount of load that it takes to damage a forged aluminum wheel, if you're just static, if you're just putting load on it, is unbelievably high. You're not going to get there. No matter, it's very, very difficult. You have to put a lot,
You're going to break something else.
yeah, you're going to break a lot of other things first. You're going to be blowing out tires first. That's not the problem. But once you start putting that cycle on there, once you start putting those rotations on there, the requirement to do any damage goes way, way down. That's what's causing the problem, are more the cycles. So hopefully
Yep.
that makes that a little bit clearer.
I could bring up one thing years ago, and I'll get some good points from marketing for this one. Years ago, we forged aluminum wheel and a steel wheel, and we have these mega presses out in Cleveland where we manufacture the wheels. And what we did was put them in a press and see how much tonnage it would take to deflect the aluminum wheel against a steel wheel, and it was like 240% more pressure to deflect forged aluminum wheel 2 inches than a steel. So my calls all the time as the refuge guys calling saying, well, on front end loaders, what if I'm going to a concrete site that's throwing away really heavy loads, and that ain't gonna hurt you a bit. The hydraulics, put them in the back of the truck. It's when you get the load on the truck. That's what we're worried about. I was just telling them guys earlier the other day, we got a call from a fire company, and they are putting their repelling equipment inside our wheels, webbing, and then repelling down these cliffs. And they're like, is that wheel doesn't even, 200-pound guy doesn't even know anything, what I mean?
Right.
So
that's right.
Many stories of saying static loading is so different than dynamic. And like I said, that crush test that we did years ago really proved that there's a big difference between a forged aluminum wheel and a steel wheel.
Oh, yeah. Yeah. It's thousands of pounds to get a forged aluminum wheel to crush. If you want a static load and you want to crush it, you've got to get into the thousands of pounds. And it's only going to give a quarter inch, a half inch, something like that. And I'd have to go look at the data again, but it was impressive. You're right, Dave. Well, great discussion, guys. I think that does it. For our listeners, remember, you can always subscribe to our podcast on Apple Podcasts, Spotify, Google Podcasts, and please, if you like what you hear, share it on social media. To submit, if you have any questions or comments, if you want to take a look at the episode transcripts, you can visit our website, alcoawheels.com/podcast. I really want to thank you all for listening. We'll see you next time.
Sponsored by Alcoa Wheels, the global leader in aluminum wheel innovation, manufacturing, and technology. Inventing the first forged aluminum wheel in 1948, its team of experts continue to develop the most lightweight, efficient, and high-performing commercial vehicle aluminum wheel products. Bringing you revolutionary innovations like Alcoa DuraBrite wheels, Alcoa DuraBlack wheels, the new Alcoa Wheels hubboard technology, and the lightest truck wheel on the market, Alcoa Ultra One 22.5 by 8.25 wheel. Alcoa Wheels, the global leader in aluminum wheel innovation.